Hello and welcome to Survey in Motion, a GEOSLAM Solutions overview. In the next 15 minutes we'll introduce you to ZEB1, our revolutionary handheld laser scanner, and we'll explain how this impressive new product might complement your existing survey toolkit. We'll explain how it works and where it works best, and we'll share some customer success stories as independent validation of our claims. Let's begin with a 101 on GEOSLAM. Here at GEOSLAM, we develop game-changing survey solutions for the measurement and mapping of multi-level three-dimensional environments. Unlike traditional static scanners, which must at all costs be left untouched while actively scanning, our handheld scanning solutions work best while in motion as they pass through the survey environment. So does this mean that GEOSLAM ZEB1 will replace your existing survey toolkit? No, absolutely not. It's complementary. I'll explain why. Your existing survey toolkit may look something like this, by which I mean your existing survey toolkit may contain some mixture of these tools and technologies. You may have some traditional analog and digital measuring tools, some close-range contact and non-contact measuring tools, and some longer-range measuring tools. They each have their own strengths, they each add value to your survey workflows in different ways. Here's how the ZEB1 adds new value to your current survey toolkit. First, let's place the ZEB1 in the context of your general survey portfolio, which you're likely to assess based on some combination of your target survey environment and your need for mobility while surveying. You can plainly see that on the far left of the chart, the airborne and vehicle scan solutions provide for the best mobility in open environments, while the object and scene scanners provide for limited mobility in a mix of environments. Typically, a tripod-based terrestrial or fixed-point scanning solution provides the compromise with middling mobility across environments. Now, when I click to add the ZEB1, it lands in the top right quadrant of this chart, clearly indicating its suitability for maximum mobility in enclosed environments. Now let's compare the ZEB1 with traditional survey tools. In this second chart, we assess the offerings based on some combination of cost, speed of measurement, and the number of measurement points taken in a given time frame. It should come as no surprise that the tape measure is the cheapest option here and correspondingly the slowest in use. While the laser disto raises the bar for price and performance, it's still comprehensively outperformed by the total station, which costs significantly more to acquire but delivers a faster survey solution. As for the ZEB1, in this company it again lands in the top right quadrant of the chart, being both cheaper than a mid-range total station and providing faster measurement workflows than anything else listed. The net benefit being lower staff costs and a reduction in time spent on site. Now let's compare the ZEB1 with other short-range scanning solutions. Here in the third chart we position the ZEB1 alongside object and scene scanners like those from Faro and Dot Product and assess their capabilities for level of detail captured, speed of capture and range. While the ZEB1 also appears on this chart on the far right hand side due to its relative long range when compared to the near range object and scene scanners, this time the ZEB1 is positioned lower down the vertical axis as the detail it collects falls short of that collected by the other two solutions, illustrating that some combination of tools would be required to record the intricate details of a given space and to locate that space in a larger complex. For example, a scene scanner may be used to capture the details of a crime scene, while the ZEB1 may be used to locate the crime scene in a much larger building with many rooms and a number of routes in and out. Finally, the fourth chart highlights the relative merits of longer range scanning solutions and compares the ZEB1 with them. Using scales of range and affordability, we can again see differences emerging between the significantly more expensive airborne and vehicle scanning solutions, which offer very long range, and the highly affordable ZEB1, which delivers exceptional value for shorter ranges. Further reinforcing our assertion that ZEB1 adds new value to your existing survey toolkit, this slide lists all of the software solutions for each of the major scanner hardware manufacturers that will import scan data from ZEB1 for registration with other scan data captured using other devices. We're often asked by people if ZEB1 is a suitable tool for their intended use, so we included this slide to cover off this question. Note, unlike some sales presentations, this slide does not list applications where ZEB1 might add value, it lists applications where ZEB1 is already adding value. Indeed, we already have customers using ZEB1 in the real world to complete measured building surveys and to conduct real estate valuations for commercial and residential property. We have customers who use ZEB1 to fulfill their legal obligations for measuring and mapping underground mines and for measuring and monitoring stockpiles. ZEB1 is being used on construction sites to monitor progress, and it's being used in forests to very quickly survey and analyse tree size and density. And the ZEB1 is being used by governmental and security agencies to survey three-dimensional environments as part of their disaster contingency planning and crime scene recording activities. In fact, it transpires that the ZEB1 is being used in many more ways, the like of which we never imagined. And here's how it works. Simply put, you start by grabbing the ZEB1 and walking through your target survey environment, allowing the scanner head to nod on the spring as you progress, while measuring more than 43,000 points per second. When you've completed your survey loop, by returning to your start location, you upload the measurement data to the GEOSLAM cloud, whereupon the SLAM software works its magic to complete a point-to-point or cloud-to-cloud registration of every measurement point captured. Then, when you're ready to consume the data, our pay-as-you-go service enables you to download the fully registered point cloud in a compressed LAS file format. It's as simple as that. Scan, process, and download. This top view illustrates the broad angle of coverage provided by the scanner, with a small blind spot of just 90 degrees conveniently located between the scanner and the person holding it. Of course, with a Class 1 eye-safe laser on board, there's no danger to any operator using the ZEB1. Now, looking from the side, we can see how the nodding action of the scan head enables the scan swath to measure points on the floor below and all the way up to the ceiling above. I mentioned the pay-as-you-go model earlier. Here I'll explain in a bit more detail how our low-cost processing model works. While scanning with ZEB1, the system records the unique path travelled and measures this path using GEOSLAM credit cubes, or GCCs. Each GCC measures 2 meters wide by 2 meters long by 2 meters high. Note, this is not a measurement of the environment being scanned with ZEB1, it's a measurement of the unique path walked while scanning. You may therefore think of a GCC like a three-dimensional floor tile. So as you walk through your target survey environment, you'll pass through a number of three-dimensional floor tiles, the total number being the record of three-dimensional distance travelled and the factor by which your download fee is calculated. Because the total count only includes unique GCCs, you may pass through the same GCC on multiple occasions while only adding it to the count once. Make sense? If not, go back to the start of this slide and listen again. It's a simple, low-cost, zero-risk concept that's easily misunderstood. As for pricing, we offer substantial discounts for high-volume purchases, and we offer a range of purchase options from monthly and annual subscriptions to one-off bundle purchases to make sure we have solutions for all customer needs. With all other survey tools, there are good and bad workflows which deliver variable results. This slide sets out to clearly position when you should and when you should not be using the ZEB1 to gather survey data. Typically, the green boxes indicate survey scenarios for which the ZEB1 is ideally suited. Orange boxes are used to encourage a more cautious or circumspect approach, and red boxes are used to flag survey scenarios which will be better served by some of your other survey tools. For example, looking first at the green boxes, it's clear that ZEB1 is perfectly suited to measuring and mapping multi-level feature-rich enclosed environments. It works ideally for reducing the cost of survey and for reducing the amount of time spent surveying on site. It's also very well proven for completing stockpile analysis and real estate valuations, for measuring building floor plans and forestry environments, and for recording crime scenes and locations of underground mines. Now let's take a look at the orange and red boxes. Here we see that ZEB1 is less well suited to open survey environments, but if these environments are feature-rich, then the ZEB1 will likely work very well, whereas if they're feature-less, you should consider an alternative solution, as our SLAM software will struggle to make sense of the data. Similarly, the ZEB1 is not well suited to wide open environments which typically lack features. A very long-range scanner solution would serve you better here. If you're surveying buildings to gather data for detailed design, the ZEB1 is very well suited where your intended construction will be in situ, using traditional building materials But if you plan to use your survey data to instruct off-site prefabrication of steel sections for bolting together on-site, you might be better served by using an alternative survey tool, as you cannot expect to achieve plus or minus 1 mm accuracy from the ZEB1. A common question we get asked is, how does this shake down on a real job? How many GCCs will I consume surveying a typical small building? And what will that cost me? Let's see. Here we use a sample project to answer those questions, and to indicate the levels of cost you might reasonably expect to encounter on other projects. We surveyed a building with a floor area of 370 square meters, with 14 separate rooms spread over 2 floors and including a double-height workshop. Our time on site with ZEB1 was less than 15 minutes. During this time, we collected 25 million measurement points, which later took another 15 minutes to process online in the GEOSLAM cloud. The fully registered point cloud was downloaded in LAS file format, and it measured 43 megabytes on disk. That's a nice compact point cloud, which is easily uploaded from site using either a 3G or a 4G mobile connection. Based on the distance we walked to complete the survey of the building interior, we consumed 30 GEOSLAM credit cubes, which cost us approximately £9 or $15 or 13 euros. We think that's quite a bargain. Better still, we completed the site survey 10 times faster than another survey team who measured the same building with a tape and disto. But that's not the only win here. Look at the survey plan. This column was missed by the tape and disto team. They didn't pick it up on their survey. And again here, they counted 4 steps where clearly 5 existed. While these schoolboy errors may prove costly on site, they're certainly costly to the professional reputation of the surveyors involved. And so it seems the benefits of using ZEB1 are clear. When you spend less time on site, you lower your staff costs. Couple that with our very low-cost data processing for registering your point clouds, and you enjoy dramatically enhanced collection economics. You can make reliable design decisions when you base them on accurate measurement data. And with an average accuracy deviation of just 0.1%, you can reasonably expect plus or minus 5 mm across a 5 meter wide room, or plus or minus 10 mm across a 10 meter room. And with better quality survey data, your risk of missing items on site is all but eliminated. I mean, it's really hard to take 43,000 measurements every second and not measure everything around you. Here's a snapshot of our customers: world-class universities and engineering firms, mining companies, departments of transportation, survey practitioners and police forces, all registering dramatically enhanced collection economics from their GEOSLAM survey workflows, and all enjoying great success. Covey, for example, in Denmark, is now measuring buildings 10 times faster with ZEB1, saving time and money in the process. Lachine Mine in Ireland is now measuring and mapping their underground tunnel networks with greater accuracy and more safety than ever before. Iowa DOT is now measuring and monitoring their road salt stockpiles with greater certainty to reduce the risks and costs associated with running low, or worse still, running out during the frozen winter. The list goes on. Customers across the world are enjoying measurable success with GEOSLAM solutions. At the start of this presentation, I showed you software solutions from Leica, Faro, Topcon, Trimble, Aviva, and Regal, and I told you that each one will import scan data from ZEB1 for registration with other scan data captured using other devices. But for the folks buying ZEB1 as their first scanner, we recommend some of the following. Cloud Compare is an open source software which is free to download and use. We use it at the GEOSLAM HQ and we rate it very highly indeed. Both PointCab from Germany and PointFuse in the UK provide useful tools for cutting plans and sections from your point cloud for reuse in other applications. Rhino is a class-leading surface modeling software which offers strong point cloud to surface generation tools and workflows at a very competitive price. And 3D Reshaper takes these workflows to a higher level but for a higher price. Finally, both Bentley Systems and Autodesk, the two leading software vendors for AEC markets worldwide, offer software solutions that will import your GEOSLAM point cloud for reuse in 2D drawings and 3D modeling environments. Clearly, surveying with ZEB1 to generate a GEOSLAM point cloud provides no end of reuse and manipulation opportunities for your survey data. I always like to end with this slide as so many people ask, who is GEOSLAM? What are its credentials? Simply put, GEOSLAM is a joint venture backed by winners with a track record of innovation. CSI Roe is Australia's national science agency and the inventor of Wi-Fi. 3D laser mapping is the UK's leading provider of LiDAR solutions to the mining industry and the inventor of StreetMapper, the world's most accurate mobile laser mapping system. I'd like to thank you for watching our presentation, Survey in Motion. To learn more, download case studies, or find contact details, please visit www.geoslam.com.